Hello students, I hope you're doing well again, and today I wanted to talk to you about Supplemental Lab 8.1. You look up here in the corner, and what you'll have a blank page. You won't even have a schematic on there. But what we're going to do for this experiment, we're going to take a resistor that has, or a circuit that has 4 resistors in there, and those 4 resistors are 2.2 k ohm, 1 k, 1.5 k ohm, and 3.3 k ohm. And what we want to do is go again, just read our voltage drops, look at current, and we'll read our resistance as we insert our resistors in our circuit, and then read our total resistance, and then we'll calculate power. So we're going to go ahead and do that. And what I've done here is I always recommend building your circuit in a straight line because you can sort of see what's going on real easily. You get into your circuit, take your measurements, that type of thing. This calls for a 12 volt drop here. And I've got a source that is half that. We're using a 6 volt lantern battery here. Just my 6 volt lantern battery that I picked up at Tractor Supply or someplace like that. So here's my circuit here as I'm building this circuit. It's very similar to the previous lab that we did, except this resistor here is 3.3 k ohm. So I've got a 2.2 k ohm, 1.5 k ohm, or 1 k ohm, 1.5 k ohm, and a 3.3 k ohm. So that's our setup there. Again, we're going to take this, before I put my source on here, is I'm going to disconnect my power supply, and then I'm going to measure resistance. And I'll say, oops, here we go. Measure resistance on our circuit there. And we should get somewhere around 8 k ohm. It'll be a little different for everybody, but that's what you're looking for. I think around 8 k ohm. I'm not sure what the calculated value is, but it should be somewhere close to there. Then what we're going to do is we're going to connect our source here, and that's the clip leads I have here connected to my battery. And what we need to be thinking about as we do these experiments in series circuit is that Kirchhoff's voltage law says the sum of the voltage drop is equal to the total voltage. So what that means is that as I measure voltage for R1 and then R2 and R3 and R4, all those voltages should add up to read my total voltage. And then I will want to measure current one place, and when I measure current, remember what we're going to do is we take a red lead, set this up to read current, and when it makes that sound, you know you need to change your position on your meter. And then I'm going to disconnect my circuit in any place really, because this is a series circuit, so it doesn't matter where I break it. This time I'm going to disconnect at the negative end of my power supply. And I put the 2 negative ends together and the circuits between the 2 positive leads, and now I'm reading my current. I'm reading around 0.8 milliamps. So hopefully you won't have any trouble with this experiment, but go ahead and go through there, take a look at that, and answer any questions we might have on that. I look forward to seeing you in lab.